Video, we're going to be talking about different ways to solve linear systems. Now, the note sheets that I have here, I'll be sure to link them below. If you want a copy of them, you're welcome to download it and print a copy. But as we get started, it's very important that we first recognize what we're dealing with these strategies. So a system of linear equations is two or more equations with the same variables whose solutions are represented by points of intersection. Okay, so I'm going to show you in this video 3 different methods that you can use to solve these systems of equations. Each one produces the same result, but I want you to know that one is more user-friendly than the other, depending upon the equations. So I'm going to start with the graphing calculator. So this is a piece that I want you to be sure and use the Desmos graphing calculator, which I'll be sure to link below so that you can take a look at it and we'll use it. So let's switch over to that calculator. So as you can see on the Desmos graphing calculator, we're going to click over here on the left and we're going to type in that first equation. So x minus 2y equals 5. And so you'll notice that it graphed it with the red line. And then we're going to put that second equation in the second line here. So 4x plus 3y equals 9. And you can see that it graphed it with a blue. Now, very important, as you move your cursor over here to where the point of intersection is, I want you to notice that Desmos gave you the point of intersection. So it's really nice for us to be able to use the Desmos graphing calculator to actually do the heavy lifting here, but we want to be able to interpret that our solution there is that point of intersection. So let's switch back to our note sheet now. So for my note sheet, I'm just going to draw a sketch of that graph that we got from Desmos. So you'll notice I don't even have tick marks on my graph here. It's just because I'm going to do a sketch. So I'm going to do that blue one here. Looked something like that. And again, I'm wanting to be precise, but not too precise. I'm not plotting points here. And then let me do that red one. Looked something like that. Yeah, by the way, I'm just using a little sticky notepad here for my, to get the lines to be straight. And so then I'll remember that this point was 3, -1, and that is our solution here. Okay, so for my note sheet, all I'm doing is just making a sketch of what it looked like on my graphing calculator before I give the solution there. Okay, let's look at one more here with this type. So we're going to solve the 3x plus 8y equals -32 and the 9x minus 2y. I'm going to go back to the Desmos calculator to do that. So let's switch. All right, so let's put that first equation in the first blank here. So 3x plus 8y equals -32. Nice, graphed it in a green line there. And then I'll click on the second one and let's put that second equation, 9x minus 2y equals -22. And so you can see that we've got now a purple one with the green one. And if I hover over that intersection point, see, this is a really nice because it gives us that intersection point even though they are decimals. So let's go back to our note sheet and draw our sketch and write our solution. All right, let's graph that green line here. And then we'll do the purple one. And then let's make a little note of our intersection point. And that was -3.077 and -2.846. And don't forget that that is our solution here. Now, I'm pretty for sure that these values were rounded. So we'll have to be, aware that, graphing is fine. It's a really nice method because the calculator does all the heavy lifting for us. However, if we're looking for exact answers, this is probably not the best method to go with when we have solutions that are not integers like these were. So let's look at a second method for solving these systems of linear equations. Okay, so two more systems that we can look at are substitution and elimination. So when we look at substitution, we want to identify, first of all, when is substitution best? Well, substitution is best when you notice that we have a variable that doesn't have a number written in front of it. So look at that X right there. There's no number written in front of it. That lets me know this is probably going to be a good use of substitution. So our first step is to solve for a variable. So what I mean by that is to take this equation and get the X by itself. So to do that, I'm going to get rid of the minus 2y by adding 2y to both sides. And that leaves me with X equals, now my minus 2y and my plus 2y go away. And I'm left with X equals 5 plus 2y. Okay. Step 2 then is to substitute. So what we're going to do is now take the other equation, 4x plus 3y equals 9. And you'll notice that I have x equal by itself. So what I'm going to do is where the x is, I'm going to create a parentheses that I can put this 5 plus 2y in. Now, don't forget the rest of the problem here. There we go. I'm going to put this 5 plus 2y in that parentheses, and I'm going to do it in another color so that for my note's sake, we'll remember where it came from. Okay. And now we solve. Okay. So 4 times 5 gives me 20. And 4 times 2y gives me 8y. And now I can have an equation that just have y's in it and I can solve. So 8y plus 3y is 11y. And now let's get rid of the 20 by subtracting 20 from both sides. That gives me 11y equals negative 11. Well, if I divide both sides by positive 11, you'll see I get y equals negative 1. So what I did is in the other equation where there was an x, I created space with a parentheses, and I put this side of the equation from step 1 there in the blank, or in the parentheses, I should say. Final step, well, see, we found that y equals negative 1. So now we substitute again. So we're going to substitute negative 1 for y. And the good thing is you can choose either equation. Doesn't matter which one. I'm going to do that first one. I'm going to put in a negative 1 for y. And so I've got x minus negative 2. That's really x plus 2. And if you subtract 2 from both sides, you'll get x equals 3. Now, to write your final answer, I want you to make sure you do them in alphabetical order. So I want you to write that x first and that y second. Now, friends, that solution should sound familiar because it's the exact same problem we did, the first problem we did to solve by graphing. And the whole point of doing this was that we would show that we got the same answer with either method. Okay. Let's look at the second one here, which is asking us to use elimination. Now, in elimination, we want to eliminate one of the variables. So I'm going to start by eliminating x. You could have eliminated y. It would have been okay if you did that, but I'm going to eliminate x. Now, in order to eliminate x, I need both of these to be the same, but I need one to be positive and one to be negative. So I think I can get this one to be a 12 if I'll multiply this second equation by negative 4. Remember, one of them needs to be positive, one of them needs to be negative. I'm going to leave the first equation alone. I'm not going to do anything with it. I'm just rewriting it. Now in this equation, I'm going to multiply every single term by negative 4. So 3x times negative 4, negative 12x. 4y times negative 4, negative 16y. 2 times negative 4, negative 8. Now that I have set it up, we add the equations together. So 12x plus negative 12x, that's 0. That goes away. 8y plus negative 16y gives me negative 8y. And negative 8 plus negative 8 gives me negative 16. Look at that, friends. We've eliminated the x's. And now if we divide both sides by negative 8, we get y equals 2. Very nice way to eliminate one of the variables so you can solve for the other one. Now, we only have half of the solution. So we've got to go find the other half. And again, we do it the same way we did here. We sub 2 for y. You get to choose whichever equation you want to do that in. I'm going to do it in this second one just because it looks a little easier because it has smaller numbers there. So let me do that. I'm going to put a 2 in place of the y. And I'm going to solve. So 4 times 2 is 8. Then we'll subtract 8 from both sides. That gives me 3x equals negative 6. And of course, if we divide by 3, we'll get x equals negative 2. Now remember, when you write your answer, you want to write them in alphabetical order, just like that. And that is our elimination method. Now, the beautiful part of this is that you get to decide which method to use. Most of the time, you're going to get to decide. So how do you choose? Well, remember back in substitution, I said that most of the time substitution is best when there's a variable without a number in front of it. So when I look at number 5 here and I see that there are numbers in front of all the variables, I begin to think that I probably should do elimination. And you get to choose if you want to eliminate the x's or y's. This time, I'm going to eliminate the y's just so I can do an example of that. So with a 3 and a 4 there, I have to think, okay, what number could I get in front of both of those y's that would be the same? And I'm thinking 12, okay? But in order to get a 12 there, I'm going to have to multiply this first equation by 4. And I'll have to multiply the second equation by negative 3, because remember, I want one of them to be positive and one of them to be negative. By the way, these little arrows here and times 4 and all that, that's just notes for me, okay? So in the first equation, we multiply every term by 4. So 7x times 4 is 28x. 3y times 4 is 12y. And 9 times 4, 36. Then let's multiply this second equation by negative 3. So 4x times negative 3 is negative 12x. 4y times negative 3 is negative 12y. And negative 4 times negative 3 is 12. So we'll add those together. So 28x plus negative 12x, that'll give me 16x. Notice my 12y and the negative 12y cancel each other out very nicely for us. And then over here, I get 36 plus 12 is 48. If we'll divide both sides by 16, we'll get that x equals 3. So last step to find the other variable. So this time we're going to sub 3 for x. You get to choose which equation you want them in. I'm going to put it in this first equation. So 7x plus 3y equals 9. And I'm going to put in a 3 for x. 7 times 3 is 21. And we'll subtract 21 from both sides so that 3y equals negative 12. And now if we divide both sides by 3, we get y equals negative 4. Now remember, when you write your solution, be sure to write it in alphabetical order, x and then y. So I hope these three methods, you see the value in each one. The graphing, I think, is a really easy method, and we let the calculator do the heavy lifting with it. But these substitution and elimination provide us a little bit more exact answers when we need to do that algebraically. Now, I would be remiss if I didn't give you a few examples of when we use these systems to help us solve word problems. So again, this note sheet is located in the description there. If you want to download a copy of it so that you have these word problems, please do that. We're going to take a look at, first of all, writing a system of equations. So we'll look at writing two equations and then solving. So my first one, a shipping company charges a fixed amount for their services and a certain amount per mile. If a 50-mile trip costs $112 and an 80-mile trip costs $57, find the fixed cost and the cost per mile. So notice that they're telling you what you're looking for. So I'm going to do F as the fixed cost. And I'm going to do M as the charge per mile. So let's look at that first one. If a 50-mile trip costs $112, so in order for a 50-mile trip to happen, I've got to have a fixed cost plus 50 miles times the mileage charge, and that's going to give me $112. Then it says an 80-mile trip costs $157. So that's going to be, for an 80-mile trip, my fixed cost plus the 80 miles times the mileage cost, and that gives me 157. So very important that I write my equations first and then I look to solve. Now, this one could go either way. Because there's no number here in front of the F, I could use substitution. But I also see that these two variables have the same number already written in front of them. So I am going to use elimination here. Okay. Because they have the same number written in front, all I really need is I need one of these to be negative. So I'm going to multiply that second equation by -1. I'm going to leave the first equation alone. So that first equation is going to stay F plus 50m equals 112. And then I'm going to multiply the second equation by -1. So F times -1 is negative F. 80m times -1 is negative 80m. And then negative 157. Okay, now we're ready to add. So F plus negative F, those are going to go away very nicely for us. 50m plus negative 80m is negative 30m. And then if we add these two together, we'll get negative 45. You can check that in your calculator there. Then if we divide by negative 30 on both sides, we get that the charge per mile is $1.50. Okay. Now, my last step to solve is I'm going to sub $1.50 for M. And remember, you get to choose whichever of the two equations you want to. I'm going to just use that first one. And in place of the M, I'm going to put 150. Okay, so I've got 150 times 50, and that's going to be 75. And then you can subtract 75 from both sides, and I'm going to get 37. So my answer is that the fixed cost is $37 and cost per mile is $1.50. Okay. So it really takes some practice. Practice makes progress to write your equations. So let's look at another example. Mrs. Mueller vested $1,400, part of it at 5%, the rest at 8%. Her total annual income from the investments was $100. How much did she invest at each rate? Okay, so let's start by doing this. We'll do a little chart here. We'll do the rate. Let's do the amount invested. And then we'll do income. Okay. This will just help us to organize the information. So if you'll notice, the first investment was at 5%. Now I'm going to do that 5%, but I'm going to do it as a decimal. So I want you to think of that decimal being behind the 5, and then we're moving it 2 places over. So my first investment was 0.05 rate. Okay. The amount invested, I don't know. So I'm just going to call it X. But then I get my income by multiplying these two together. So I have 0.05x. Okay. Let's do the second investment. It was at a rate of 8%. So if I move that decimal, then I get 0.08. Now here's the tricky part for the amount invested. If she invested $1,400 total and X of it was invested at 5%, then the second investment has to be 1,400 minus X, whatever is left over. Now let's multiply those. Notice that when I multiply the 0.08 times the 1,400 minus X, I've got to use a parentheses. Okay, now I'm ready to write my equation. Because I know that the total annual income from these investments was $100, I know that when I total these, hint, hint, when I add them, I should get $100. So let's write that equation. 0.05x plus 0.08 times 1,400 minus x equals $100. Now this one, I've already made the adjustment. So you'll notice my equation only has one variable. Very nice for us, okay? So let's go ahead and distribute that 0.08. We'll distribute our 0.08 here. And let's see, when I do my 0.08 with my calculator times the 1,400, I get 112. Okay. And then times negative x is 0.08, x equals 100. All right. Now, if you'll do this in your calculator, 0.05x minus 0.08x, you get negative 0.03x plus 112 equals 100. Now let's solve. We'll subtract the 112. And that leaves me with negative 0.03x equals negative 12. And then if you will divide by the negative 0.03, again, do this in your calculator. Let the calculator do the heavy lifting there. You get 400. Okay. So what does that mean? Well, we'll think about where X was in our chart. That means she invested $400 at the 5%. So she invested $400 at 5%. And let's think about then, what did she invest at the 8%? Well, remember, she invested $1,400 total. So if she invested $400, she must have invested $1,000 at the 8% level. So that is how we set up the equation. But I think the chart is key. I think the chart is the part that's going to make the difference for you being able to organize all of your information in these classic types of system equations. So I hope this helps you as you solve your systems of equations using the graphing method, the substitution method, or the elimination method, and then also taking a look at some word problems and how to set those up.